now is that we get, well, before we do that, domain and range. What was your domain and range again? So your domain is your possible. This will be your possible. So you have possible x values and possible y values. Usually when we write out domains, we write them out via what they can't be. Especially these rational functions, we a lot of times have vertical asymptotes and horizontal asymptotes and things like that. So what happens a lot of times is that it's easier to write out that the domain x can't be 3 or something like that. All right, instead of saying all real numbers except 3, this is just a little bit easier to write. Next year when you guys get into pre-calc, you'll write it like this. Domain, all values of x such that x cannot equal 3. And you're going to use what's called set notation. It's fun. J little face x such that x not equal 3, J little look in the other direction. You shake your head at me. Thank you. Try to show something funny. So what happens here is that you get all of this mumbo jumbo. And what I did for you guys on your sheet here is I kind of whittled it down to just a little bit of information so you can kind of add to that as part of the notes. You don't have to write down everything. What I want you guys to think about here is that what we're going to do now is that we're going to take polynomial of some degree divided by some polynomial of some other degree. Okay. I'm going to say that it's m in the numerator and n in the denominator, because I think it's how it's written out on that little note sheet. When we talk about it like this, we're saying that you're going to have nth degree polynomials that will allow you to, you'll have some sort of rules for graphing. And it's pretty basic. But the thing is that when you have upper degree polynomials, as opposed to what we did yesterday, you kind of have to go through this. And once you do this a couple of times, it's pretty quick. Okay? So the first one that you have to worry about is that you have x-intercepts. X-intercepts are always at the zeros in the numerator. Okay. Now, remember, this is for when you have different degree polynomials. Okay. Your vertical asymptotes will always, always, always be zeros in the denominator. That's always going to happen, no matter what kind of rational function we have. And the reason why I'm putting the s in parentheses because sometimes it could be a squared term in the numerator and a singular linear term in the denominator. So you might only have 1 0, you might have 2 zeros. Eventually you might even talk about what's called a whole, one that cancels, one that factors itself out, but you have what's it called? Jump discontinuity thing? We'll figure it out. I forgot. What else was there? And then your horizontal asymptote is where things get funky. Is one of 3 cases. Okay.
Can you go up just a little bit?
Yeah. That's my touch. Make sure I put the editing red. So your horizontal asymptote could occur at one of 3 different occasions, or one of 3 different scenarios. The first one, and this is where the degrees come into play. If the degree of the numerator is less than the degree of the denominator, your asymptote is at y equals 0. This is talking about the degree, okay? So if the numerator is an x squared and the denominator is x, this wouldn't work. It would have to be x over x squared. So, does that make sense? You're looking at the degrees. Okay? You're looking at the degrees. If the degree of the numerator is bigger than the denominator, there is no asymptote. A-S-M-Y-E-T-O, whatever. That's why I have a degree in math-ish. I shouldn't say ish, I really do have a degree in that, like a fake one. It went in like a Cracker Jack box. They still have it? They still practice it?
Yeah, we do like tattoos and stuff.
And lastly, if they are the same, then your asymptote play just like we did yesterday. Remember how it was x over x? It winds up just being the coefficients, the a over b. Where a and b, these are the leading coefficients. I know. Okay. Why should I start spelling anything correctly now? So basically what happens here is you have these three basic scenarios. And it's no more than, well, if I have y equals 2x cubed plus 4 over x squared minus 6. I can go through the steps of all this stuff to figure out where all of my asymptotes and intercepts and everything are going to wind up playing or occurring. It's kind of a bad example of cube here, but for right now, if I wanted to tell where my horizontal asymptote is, which of these degrees is greater?
No,
The top. So where's my asymptote?
0.
There isn't one, because this degree is bigger than that. Okay? So that's the kind of thing you're going to do. You go through the process and check those things out. Okay? My vertical asymptotes would be at plus minus root 6. Okay with that? My x-intercepts would be, if I set this equal to 0 and solve it. So it's going to be negative 2, the cube root of negative 2. Yeah, some nasty number. All right? But that's what you're able to do. Now, obviously, I just made something up real quick off the top of my head. It's not as clean as what the other stuff would be. So what happens here is that we're going to look at some pretty basic ones. Let me just grab one real quick. Real basic setups. And you should be pleasantly surprised. Even though it looks like it's going to be awful. Change up. So let me show you. Let's try this. Y equals let's do that one first. And we'll go through each one of the steps. We'll plot it, graph it, and go through all of it. So if y equals 4 over x squared plus 1. How'd your final go? Your first hour final go well? What day is today? Today's Wednesday? Because last Wednesday was finals, the first day of finals, and they reset the bell. The bell started 7:40, but the bell rang at 8:30, didn't it?
Please disregard that last one.
I remember first period.
So go through the list. First thing, according to our stuff from today, is that we look for the zeros of the numerator to get x-intercepts. Is there a 0 in the numerator?
No.
No. So is there an x-intercept?
No.
No. So we know that there is no x-intercept. All right. No x-intercept. I go to the next thing. I find the zeros of the denominator. If I find the 0 of the denominator, well, it's I. Can I graph that?
No.
No. So do I have zeros, real zeros in the denominator? No. So there's no vertical asymptotes. Okay? And lastly then, excuse me, lastly, I have to talk about my horizontal asymptote. Which one of the degrees is higher, numerator or denominator? Denominator. So if the denominator has a higher degree, where's the asymptote? At 0. So I go ahead and do this. I know that I have an asymptote at y equals 0. So since m is less than n, the horizontal asymptote is at y equals 0. Those are the first 3 steps that I do. But now it's like, okay, well, what does the graph look like? Well, can't we now pick, since we have no worries about left and right ranging, I can't worry, or domain-wise, I don't have to worry about picking numbers on left and right of a vertical asymptote. This is when I would say pick your -2, -1, 0, 1, and 2, just to get an idea of what it looks like. Okay? And I'm just going to plot. What's -2 squared? 4. What's 4 plus 1?
5.
So it's 4 or 5. 4/5. So at -2, it's almost finished. What is -1 squared?
1.
What's 1 plus 1?
2.
What's 4 divided by 2? 2. So at -1, we're at 2. What's it going to be at 0? 4. Very good. And notice it comes back down. And what is it going to approach as it tails? It's going to continually get closer and closer to what?
0.
0, because it's going to approach its asymptote. So it's going to do this. It's a speed bump. It's a speed bump you probably don't want to hit at a very high rate of speed.
It's the speed from going at any speed.
No.
It would destroy your classes.
Much.
I didn't see that in like a cartoon or something like that.
It's like, you ever play the game Excite Bike?
Yeah, I did.
That's like Excite Bike, right?
Yeah, that's Excite Bike.
I love Excite Bike. So, again, what's nice about this process is that there's a step-by-step way to get the rough idea. And once you get asymptotes and going, then you can go back to what we did yesterday, plot values on either side of the vertical asymptotes, or in this case, we just pick some numbers. Yes, sir?
Wait, how did you get the horizontal
Because my degree of the numerator is smaller than the degree of the denominator. All right? Not terrible?
No.
Let's do another one. Let's try this one, a little bit more difficult. Maybe. So we have y equals x squared plus 4x minus 5 all over x minus 6. Oops. So first thing we're going to do is we're going to check for x-intercepts are at the 0 of the numerator. So it means we have to factor. What times what is -5 you add together to get +4?
5 and -1.
So it's x plus 5, x minus 1, which gives me zeros then at 1. Those are my 2 zeros.
How's the x-intercept work with 0 with the denominator?
Numerator. The vertical asymptotes are the zeros of the denominator. So right off the bat, as I start to piecemeal this graph together, I know that it's going to cross the x-axis at -5 and 1.
So you have 2 asymptotes.
I don't know. Those aren't asymptotes. Those are just zeros. Okay. That's just where it's across the axis. I only have one asymptote here, one vertical asymptote, because I only have 1 0 in the denominator. Where's my 0 of the denominator?
6.
It's 6. So the second step would be to get my vertical asymptote, is at x equals 6, and I plot that. Okay? Now I've got zeros, vertical asymptote. The last thing to look for is which of the three cases the degrees go. Well, the numerator has a higher degree than the denominator. So that means that the numerator is larger than the denominator, so where is the 0 going to be located at? At 0. Okay, I think that's when it's greater than? I believe that's what it said, right?
No, it says there's no.
Oh, no asymptote, sorry. I forgot about it. So there's no horizontal asymptote. All right? So don't have to worry about that. There's no range restriction here. Your domain is going to be everything except for 6. Your range will then be all real numbers. Okay? Now, I don't even know what to even start doing with this. So what do you think the easiest thing to do now to go with? You can pick some numbers here. It could be kind of nasty. I'd like to see what's going on this side of the graph, so I'm probably going to have to pick maybe like 7. Yes?
Just like the domain and range was again.
The domain in this case, the domain is going to be all x values not equal to our vertical asymptote at 6. Our range, since we have no horizontal asymptote, since there's no horizontal asymptote, that means there's no restriction upon the y values. So the range is going to be all real.
But could, if it has like no restrictions, that means it could be a negative number too, right?
Correct.
So then it's negative numbers. What's a negative numbers
Good one. Okay. Now, from there, it's a matter of, again, picking up a bunch of numbers and going for it to see what's happening. What I'd like to do just to kind of help through with this is use my table for right now, just so we don't have to worry about this all day, because I want to show you the one more example. So if I want to look at my table to help pick out values, basically this is the same thing that you could be doing with the calculator just by plugging and chugging. You guys okay with that? So what I'm going to do is just put this in my calculator, alpha y equals, make the fraction bar, x squared plus 4x minus 5 over x minus 6. And if we look at it, hopefully this all shows up. I don't think it's all going to show. Okay.
What's the ratio?
It didn't show anything on the other side of the asymptote, did it? But if you go to our table, you'll see that there are numbers there. Why does it say error at 6? Because it's an asymptote. Okay. So you know that as you're coming through, if you just scroll through your table here, you'll see certain values that you'll be able to plot. So we know at 5 it was 0, at -4 it was at a half. It went up to 9/8, which is just a little bit more than 1 at -2, and then it started to come back down. So we saw that it does this hook, and it approaches the asymptote. Okay. But I want to show you that if you continue to scroll through, once you get on the other side of that asymptote, where did it wind up?
72.
72. So at some point in time,
When it crosses the asymptote, it rockets up.
it's up here at 72. And then it works its way back down.
Wait, the little mark is still there from the year.
I'm sure it is. And then it slowly works its way down. So here you're at about 45. At 11, you're at 32. So what's happening is that on the other side here, if we change our window, and I change my x maximum to be, I don't know, 50, and maybe my y maximum to also be 50, we might be able to see the graph a little bit better, because eventually, what's happening is that you've got this curve doing this, and then up here, it's coming down and doing this. Between those two, since the degree of the numerator is one larger than the degree of the denominator, there's actually what's called a slant asymptote. You're like, damn it, I'm done.
Oh, you broke it.
I didn't mean to, but it was funny because you just put it down. You're like, I'm out. There's what's called a slant asymptote there. Okay, and what we're I know, it's pretty cool. That's a good forceful way of. There's actually a really easy way to write the equation of that line. Because I'm going to ask you to do that. What? What's the zero of the denominator? 6. Okay. What are the coefficients of the numerator?
We'll go back to this.
4.
Are you serious?
Yeah, what?
I don't remember how to do it.
And then that's what, 55? Okay. So what'll happen here, well, I might not get to this today because we're running a little long here, is that I'm going to show you guys how you're going to be able to write the equation of the line of a slant asymptote, because it is something that does exist. And it is something that you will do quite often in pre-calc and in calculus. So I figured, what a better time to at least introduce you that something does happen there, and we're going to be able to figure it out by writing the equation up by using the slant asymptote stuff. Okay? We'll worry about it as we get a little bit more into this. Okay? It's not stupid.
You can need this when you become a millionaire.
All right, this is where they're equal. So we'll probably make this be the last one. Right? Gotcha.
You're gonna need
Yeah, you guys might ask this. So, same idea. We go through the whole process again. We're going to get, first thing we do is find our x-intercepts. We're obviously going to have to factor the numerator. So what's 3 times 10?
30.
What's 30? You add together to get negative 13. Negative 3, negative 10. So you'll have to factor. So we have 3x squared.
Are they all factored by
What's that?
Like, are they gonna be that easy to factor?
Usually, yeah. They're not going to really mess you up too much. So then you just factor by grouping. So we take out 3x, we have an x minus 1. Take out the negative 10, we have an x minus 1. So we have 3x minus 10 and an x minus 1. So we have 10 thirds and 1 for our x-intercepts. Ten thirds is what? 3 1/3? So 3-ish and 1. Do I have any real zeros for the denominator? No. So there's no real zeros for the denominator, so is there a vertical asymptote? No. The degree of the numerator and the degree of the denominator are the same,
Horizontal is 3.
which means that your horizontal asymptote is just going to be your coefficients. Y equals 3, because it's 3 over 1. What's your domain? Very good. What's your range?
Anything but 3.
Any all y values but 3. Okay. Yes, ma'am.
Wait, is there a situation where they would have like 2 different coefficients?
What do you mean?
Like, you said like if m and n equal each other, then you take the coefficient?
Yeah. Oh yeah, just the coefficient of the denominator is 1. This could have been 2x plus 8, and then it would have been the asymptote would have been at 3 halves.
Oh.
It's just like what we did yesterday, how we had the ax plus b, cx, and d. It's just you're just pulling the coefficients out. That's all it is. That's all. You just pull them out and you simplify the fraction. Let's do this then. Let's just do the steps of all x-intercepts, vertical asymptotes, and horizontal asymptotes, just labeling all that out for tonight. We'll worry about how we can adjust and find points and stuff like that for tomorrow, and we'll just kind of tie all this together. Okay? Is that okay? Because I don't think we don't have enough time to go into how you start guessing and checking certain values. So let's just do these. I'll give you what, 9 of them? That's plenty.
So we don't need to graph.
No graphing today. If you want to, actually, you know what? It wouldn't be a bad idea just to plot the zeros and the asymptotes, and then we'll work on tomorrow how do you pick numbers within those domains to make your curves go without pressing buttons on your graphing calculator. You know what I mean? Try not to let you use a table. Let's do that. Okay. You got to label them out anyway. So this is in 9.3 old book, and I'll post this on the calendar here in a minute. It's page 550, numbers 11 through 19. And all I want you to do is, you want x-intercepts, vertical asymptotes, and then 3 would be your horizontal asymptotes. Let's just get in the habit of labeling those out, because once we are able to label those out, then we can plot them, because those are the easy ones to plot. Those will always be the easiest things to plot on a graph. The hard part is going to be, how do you come up with the rest of it? And then how do you know when you have to worry about this? And we'll talk about this tomorrow. And then how to pick points, okay?
I didn't question the calculator. Oh, that's this one.